I did get some requests about doing some later streams, so I will put this recorded video up first. So I'll stop the stream and it's still about 3. I'll make those edits real quick so it doesn't have like the very lengthy 12 minutes in the beginning of just y'all waiting, and then cut that off. And then I will redo the stream again, so I'll come back live again. That way, if anybody has any questions that is later, I'll stay on for about another hour or so after that. You can just ask questions and we can work through those problems. But it'll be some downtime for about 10 to 15 minutes. Alright, so with pre-algebra today, I figured I'd keep going with slope-intercept form, which we stopped with yesterday. So with slope-intercept form, we were just going over figuring it out from a graph. So I'm going to do 2 problems from that today, and then I'm going to show you how to find your slope-intercept form equation from 2 points. So for given a graph, and I'm going to try to graph this as best as possible on here, so please forgive me if it's not really perfect. So we're going to have our, let's see. And you know what, I'm going to bring x-axis down just a little bit lower. And I'm going to give you all some dots because I know this line came out super awful. So I'm going to give us a point here, and let me change that color. So we have a point here, which is going to be an important point, which we're going to go over in just a second, and a point right here. And again, I know that line's not perfectly straight and doesn't hit through there exactly, but those are the points that I was trying to strive for. As we talked about yesterday, we have our slope-intercept equation, so that's y equals mx plus b, where m is our slope, and you can also hear that as being our rise over run, but I don't like to use rise over run as much, only because a lot of people just, if you hear the rise, you only think that it's going up, when in this case, if you look at our line right now, it's actually just, it's a negative slope, so it's heading down to the right. So another way to say that is change, that's what that little delta symbol is, it means change in y over change in x, and what that means is what's our change in our y coordinate over our change in our x coordinate. So how did we get from this point to this point in terms of going up or down and then left or right? Now with coming up with your slope-intercept form equation from a graph, and I'm sorry, we also need to talk about b, which is our y-intercept. Our y-intercept, and that's where it crosses the y-axis. So it crosses where it crosses the y-axis. And that is our important point that we need to find, which it was kind of easy to see. So here's our y-axis, right here is our up and down, our vertical point, our vertical axis. So if where it crosses, we're going to count. So here's the origin, 0, 0. We're going to go up 1, 2, 3, 4. So it crosses at the point 1, 2, 3, 4 we said. So if you were to write that as an ordered pair, that'd be 0, 4. But it crosses the y-axis at a y-coordinate of 4. A y-coordinate of 4. So that's what we're going to put in for b. So b equals 4. And it's positive, because it's on the positive side of the y-axis. Now we need to find out what our slope is. So our change in y over our change in x. So how did I get from this point to this point? So you can do this one of two ways. Yesterday I showed you you can use the equation by having the 2 points. So if we were to look at this point, this would be at 1, 2, 3, 4, 5, 6, 1. So we could use these 2 points to come up with our slope. And the equation you would use for that, for the slope, would be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now let's say you're not going to remember that, or you're nervous about remembering that. I also showed you about putting it into a chart and then just finding the difference that way. But honestly, with a graph, the easiest thing you can do, so I'm going to switch this color up real quick, is just to count. So I need to be in line with this point. If you're reading left to right, we would move from here to here. So we're going to go down first. So 1, 2, 3. Now we're in the same row as our next point, so that was down 3, 1, 2, 3, and then we're going to go over 1, 2, 3, 4, 5, 6. So that's a plus 6 because we're going in the positive direction. So if I was to write that, our change in y is negative 3 because we went down, so that's minus 3 over positive 6. Now, the thing about that is, don't forget we have to simplify. So to simplify, we need to see if there's a number that goes into negative 3 that also goes into 6. And in this case, there is. And it's 3. So 3 goes into negative 3 negative 1 time. And 3 goes into 6 2 times. So our slope would be negative 2. I'm sorry, negative 1 over 2. So negative 1 half. We got our m, we got our b, we can plug in now what we know. So our equation for the line is going to be y equals negative 1 half x plus 4. So hopefully that makes sense. I'm going to give you all another problem where to go through too. Just erase this because I'd like to keep the graph up. So this is going to go away for a bit. It's just best to start over. It's fine. Alright, so our next point. Let's see here. So we go down. This time I'm going to give you a y-intercept though that is a negative, so we're going to work our way up with a positive slope, maybe, or maybe we'll do a negative slope. Let's see. Let's do a negative slope. So I'm going to go ahead and give you these points just so you can see it a little bit easier, so I know if I a pretty awful line, you'll understand that it's all the way up here. Alright, so we need to find out our slope-intercept form, so I'm going to write that again up here. So slope, intercept. So that's going to be y equals mx plus b. And you need to remember this because you will see this again next year in algebra. Again, m is our slope. And in fact, let's go ahead and change some colors up here. So let's make our slope make it purple. And we'll make y-intercept, since it's already blue, we can already go ahead and do that. So let's find our y-intercept first. So where it crosses the y-axis right here. So our b value is going to be 2, 3, 4. So the y-intercept's at 0, -4. So that means our b value is going to be -4. So now we need to find our slope. So again, you could find it between the 2 points. In fact, we'll do it both. We're going to show both graphically and having the 2 points. So if I was to plot this, this is at 0, at -1, 2, 3, -3, 2. So before we do it graphically, we'll just do it with using y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Alright, so moving left to right, we'll make -3, 2 our first point, and 0, -4 our second point. So our second point has a y value of -4, and our first y value, back all the way over here, is a 2, so -2, over, our x was 0, minus -3. Notice I just didn't drop the negative. I know we're subtracting, so you think that would be the minus symbol there, but no, it's a double negative here. And let's color code this a little easier. So our x's, so we got 0, 0. This would be too close. Let's start with the So hopefully the color coding kind of helps you see where it's all going, but so that's what we do in there. So if we subtract that, so -4 minus 2 is going to be -6. In fact, just to help y'all out too, let's see. Why did that come up? Hold on one second. I was trying to get the calculator to show up, and it doesn't want to be working for me. So give me 1 second. There it goes. Okay. So you can use Desmos, so negative, clear all that. Negative 4 minus 2 is your -6, just like how we wrote it. And then we can try the next one. So 0 minus -3. I'll show you this in just a second. So 0 minus -3 gives us a +3 on the bottom. on here, we would have a positive 3. So can we simplify this? Yes, in fact, this came out just pretty similar to what we had, except it's going to be the reciprocal, so instead of it being negative 1/2, it's negative 2 over 1. And that can simplify one more time. Negative 2 divided by 1 is just going to be negative 2. So that would be our slope, m value. Now let's say you didn't want to use the equation. Let's just see if we were to do this graphically, if we get the same thing. So we should get something along the lines of negative 6 over 3. So again, going from left to right, let's move down first. So change in y. So we're going to go down 1, 2, 3, 4, 5, 6. That's down 6. And then over 1, 2, 3. So over positive 3 because we're moving to the right. So we got the exact same thing. Now if you had wanted to go the other way, then they would have been the additive inverse you would have had if you went from right to left. You'd have a positive 6 going up and a negative 3 going to the left. You'd still get the same answer as well. So if we were to write this out in slope-intercept form, you have y equals, our m was negative 2. X is going to be our input, so what we can put into the equation. And then in this time, since we have a negative 4 for a b, instead of having plus 4, we're going to have minus 4, because adding a negative is the same thing as just subtracting a positive. So this would be our final answer. So that's a negative 2x minus 4. Alright, so haven't had any questions yet, so please feel free, you can put questions or comments in the chat, and we'll post up too as well, so people who are watching this later can see what you asked, and that way if I have to go over a question that you had, they can still see it too. Alright, so now we're going to go over two problems where you're then given the points rather than you finding it graphically. So in a situation like this, you would be given two ordered pairs, and they would ask you what is the slope-intercept form equation for between these 2 points. Now, 90% of the time this year, you're going to be given the slope-intercept as one of the points, so, and you'll know it's the slope-intercept because as we talked earlier, so I'm going to draw a coordinate plane one more time. So the y-intercept occurs by crossing the y-axis. Now, we remember that the origin, so the very center point, is 0, 0. So if you move along the y-axis, you never change your x-coordinate, so that will always be 0. So you could have something like 0, 4, so then your y-intercept's at 4. You could have 0, negative 3, so your y-intercept would be at negative 3, and things of that nature. So, and I'm sorry, I kind of wrote that off screen, I'm now realizing. So I had a 0, 4 at the top. So if you were asked to find the slope-intercept form, of a function whose points went through 0, 6 and 5, 3. Okay, so we're going to solve this twice. And there is a third way, but I'm just going to briefly say that because that way I don't take up too much of yours time and we can work through two problems. So the first thing is then again, remember that slope-intercept is y equals mx plus b. B is the y-intercept, and m is the slope. And that's the change in y over the change in x. Alright, so the y-intercept is already given to us because, like I said, remember you're looking for something that has a x-coordinate of 0. So our b value, let's make that blue. B value is going to be 6. and then we're going to find our slope, so our m value, so our change in y over our change in x. Now there's two ways you can do this mathematically or algebraically. You can use y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and just fill in. So we can make this our first point or this our first point. It doesn't matter. Just because of how it's going down on the chart, I'll make 0, 6 my first point. So my y coordinate for my first point is 6, and my y coordinate for my second point is 3, so it will be 3 minus 6 over, let's actually make this easier for you to see. So I'm just gonna bring this down over here. 3 minus 6 over, so our x coordinate for our second point, and let's do PT stands for point. So our x coordinate for our second point was 5, and we're going to subtract 0. So 3 minus 6 because I have it away, that's why it's not coming up for y'all. There it goes. Okay, so click here. 3 minus 6 is going to give us negative 3. And I'm going to press enter so then we can just do the next line. 5 minus 0. So it's going to be negative 3 over 5. So I'm going to put this away real quick and rewrite that. Negative 3 over 5. So that would be our slope. Alright, now that we know our slope and our y-intercept, we can just plug in what we know. So our final answer would be y equals negative 3/5 x plus 6. Now, I said I was going to solve this two ways. So, the b is relatively easy to see because that's going to be 0, 6. It's going to be anything that has the x coordinate of a 0. So we just need to remember that. And with practice, we'll get there, but just remember that x coordinate of 0, your y is going to be your y-intercept for that point. Sometimes it could be 0, 0, so you could have a y-intercept of 0. You can go through the origin. Now, let's say you forget the slope equation here, this y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's say you forget that. Well, yesterday I showed y'all that you could just put your points in a chart or a table, so an xy table, and you can find the difference between the 2 points. So we can do 0, 6 and 5, 3. And you can also reverse these, so you can have this as 5, 3 and 0, 6 second, and you'll still get the same answer because, like I said, you would just have the additive inverse values and it will still simplify. You'll just have a negative in the bottom and a positive top. So how did I get from 0 to 5? I had to increase myself by 5 points, and to go from 6 to 3 I had to decrease by 3 points. So again, if I put that over as change in y over change in x, you still get negative 3. Ooh. Negative 3 over 5. So our slope is still the same. Now, the last thing you could do instead of solving it algebraically is to graph it. You're allowed graph paper on the SOL or on the test, and then just graphically calculate, like as we were doing, how much does it go up or down, how much does it go left or right, and so you could also do it by using it graphically. Now, I am going to show you something. We're going to do a problem where you're not given the slope-intercept, so the y-intercept, so you won't be given a point that's 0, 6. So this is going to be something new to y'all, but you will see it next year. And I figured I'd throw in a challenging problem at the end for y'all to work with. So I'm going to erase the board real quick. And I'm going to write the slope-intercept again at the top. Make sure you can see that. So So slope-intercept again is y equals mx plus b, right? So you're going to be given 2 points. This time you're not going to be given the y-intercept, so our 2 points is going to be 3, 4, and what else? Other point? I said 8, 9. So, oof, that's an 8. 8, 9. Okay, so this time you can't find the b right off the bat. Like I said, this is the likelihood, or you seeing a question like this is not very likely to happen on a test or on the SOL. But again, I just wanted to give you a challenging one because you will see something like this next year. And next year you will be given 2 ways that you can solve this. I'm going to show you one of the ways. The other way, you'll be using a form called point slope, which I'm not going to go over this year because you don't need to know it, but that is another form that you will need to know next year, and you can use that to also solve for a situation like this. Okay, so first thing that we need to do is that we're going to solve for the slope. So to solve for the slope, we are going to, again, I'm going to do this twice. So the first thing I'm going to use is the m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I know we're getting close to when algebra is supposed to come in. I am going to start algebra in just a second after this problem. So if you're here for algebra, just give me just a few more minutes. Alright, so I'm going to make this 0.1. Actually, you know what? I'm going to make this 0.2 this time. That way I can show you that it doesn't matter which order you put this in. So I'm going to put this as, so my y value for 0.1 is going to be 9 this time, and my 0.2 value is going to be 4, so this is going to be 4 minus 9. And my second point's x value was 3, and my x value for my first point is 8. So 4 minus 9 is going to be negative 5, and 3 minus 8 is going to be negative 5 as well, and this actually came out to a nice number. So negative 5 divided by negative 5 is just going to be 1. So we have a slope of 1. Now, just to show you, just in case, so you can see the math, you are allowed a calculator, so let me just clear all real quick and bring that back up. So 4 minus 9, negative 5, and 3 minus 8, negative 5. So we got negative 5 divided by negative 5, and just in case we forget, we can even put this in the calculator, and you still get 1. Alright, so put that away, clear all. Alright, so we got our slope now. So we have y equals, I'm just going to write this as if we have almost everything. So but the problem is, how do we get this? Well, what you have to do is you're going to pick one of these points. I don't care which one. And in fact, what I'd like you to do is, again, I'm not grading anything, none of these are required, I'm just giving you some review while we're away for the bit. So I'm going to solve it using the 0.89. I'd like you to do this again later using 3, 4. So what you can do is you can plug in your x and y value in for x and y. So my x value of 8, I would put 1 times 8 plus b. I don't know what b is, so that's still going to stay b. I don't know what that is. That's an unknown. And then my y value for this situation is 9, because I know at an x value of 8, I will get 9. So I'm just going to solve as if I was solving for a 2-step equation or a 1-step equation. 1 times 8 is going to be 8 plus b. So then what would I do? I need to get b by itself, so I need to do the inverse operation to bring it over. So I'm going to subtract 8 from both sides. 8 divided by negative 8 is going to cancel to be 0. And 9 minus 8 is going to be 1, so I have a b value of 1. So then I just plug it all in. So I get y equals, notice that I brought it back to y, so we're just finalizing our slope-intercept form equation. So y equals our m value of 1 x plus 1. Now, you won't see it like this because anything times 1 is just itself, so you'll most likely just see y equals x plus 1, and that would be your final answer. Now, I'd like you to try again. Again, I'm not grading anything. This is something that you can try at home, but that's another point you can use right there. I'm going to stop there for pre-algebra. So if you have any questions, you can still write in the chat, and I can go and answer those after I do some of my algebra questions. I am going to stop the stream after 3 just for a little bit so I can edit the video so it's not a massively long video for people to watch from home in case they have limited data. And then I will re-upload, I'll start streaming again starting around 3:15, 3:30, as long as it doesn't take too long, or I may just make a whole new stream where people can just ask questions and we're not having to worry about time length or anything. But for pre-algebra, I miss y'all. I hope you're doing well. And I will see you then sometime next week. I'll post that in Google Classroom. Alright, so now on to algebra. Alright, so for algebra today, I am going to go over law of exponents, and I'm also going to go over simplifying radicals. So with law of exponents, yesterday we went over pretty in depth, I think, for everything. So I'm going to do again, well, I shouldn't say pretty in depth. We went through a lengthy review over it, but we went not quite in depth, but we can do a quick review one more time. So remember the first thing we learned, anything with a exponent of 0 is going to be 1. Anything with a negative exponent, we're going to do the opposite of, so this would be 1 over x squared, or if the negative was in the bottom, I'm going to flip that, so this would be x squared. And then, so this is 1, this is 2, and then the third thing was when you're doing the product rule, so if we do x3 times x to the 4th, you're going to add the exponents again just to remind you, so that's x, 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 and this is times x, 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 x. So how many do we have total? We have x to the 7th, so instead of expanding this all out and rewriting it, you can just add the exponents, so 3 plus 4 is 7, and then same thing, I'm actually going to reorder this, the same thing with the division rule, you would just be simplifying, so instead of adding the exponents, you're going to subtract them, so if I had the opposite, so if I had x to the 3rd over x to the 4th, instead of writing that as x over x over x over x over x over x over x, so these would just cancel, and you're left with 1 over x, or x to the negative 1, which you would write it as this. So if I did this, you could subtract, so 3 minus 4 would be negative 1, and that would still get us the same answer. So these are the same. And then the kind of fourth thing that we learned, which I'm numbering as number 5 this time, is when we raised a power to a power. So if you had something like 3x squared to the 3rd, the most common mistake was to multiply your coefficient and the exponent. That is not what we are doing. That is not the situation that's occurring here. So this is like saying 3x squared times 3x squared times 3x squared. It's the group multiplying itself 3 times. So that's like saying 3 times 3 times 3, or, because right now this has a exponent of 1, so 1 times 3, that's the same thing as saying 3 to the 3rd, and x squared, so times x squared, that's like saying 2 plus 2 plus 2, so x to the 6th, so 2 times 3 is 6. So that's how we would get this answer. Now you may see it like that, you also may see it most likely as 27, x to the 6th, that would be our answer. Okay, so those would be the, that's just a brief summary of what we were doing. So I'm only going to do one problem today since we did so much yesterday. So if you didn't see yesterday's video, you're more than welcome to rewatch that later, or stop it, go watch that one now, and then come back to this and watch this one later. It's up to you. So I'm going to write this problem down. Give me a second because it's going to be a little bit lengthy. So this is going to be 3x to the 8th y to the first. I got to look at my notebook. Hold on one second. Y to the first times 4x over 2y cubed over 2x to the 5th. That's a z to the second, and then you can square it. Now, there's two ways you can do this, and I will... Actually, there's probably more than two ways, but the two ways that you can do this is that you can simplify this first before squaring it, because this is already in a grouping symbol. And remember, your fraction bar is also a grouping symbol, so you can actually do this part first. So that's the first way, and I'm going to solve that way using green. And then the next way you can do this is to multiply this in, so multiply itself, this term by itself. So that's because we're squaring it. You can do it that way, and I'll write that way in blue. So for this one, I'm going to simplify first in green. So simplifying the inside, I have a 3 and a 4 in the top, in the numerator, that I can multiply. So 3 times 4 is going to be 12. And I'm going to rewrite that because I don't like that one. So this is going to be 12. And then you have your bases that are the x's that are the same. So you have x to the 8th and x to the negative 2. And like I said, when you have the same base, you're going to, and you're multiplying, you're going to add those exponents. So what is 8 plus negative 2? 8 plus negative 2 is going to be x to the 6. And just to show you this, that's probably best if I show it like this. So that's like saying, I'm going to just draw out this top part right up here of what's occurring. So you have 3 times x, 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 1, 2, 3, 4, 5, 6, 7, 8. And this is x to the 1 over x, so you're going to do 1 over x times 1 over x. X divided by x would cancel. X divided by x would cancel, so you're left with 1, 2, 3, 4, 5, 6 x's. I'm going to erase that real quick. So we got our x's combined for the top. Now we're going to combine our y's. So we have y to the first, which I actually gave y'all this time. They most likely will not write that as y to the first. So that will be y times y to the third, which would give us y to the fourth. That's over. There's nothing we can combine downstairs right now, so we're going to just rewrite that. This is still being squared. Again, I would go ahead and simplify before raising this power to a power, because it would just be easier in terms of the math. Again, this is kind of a choose your own adventure at this point, so I could even break this one up and show you that, and actually that is what I'm going to do. So I'm going to break this one up again, so this is going to look different. So if we had simplified still, I'm going to keep writing that in green, so I'm going to simplify again. So 12 divided by 2 works out nicely for us to be 6. So we don't have any integers in the denominator right now. We have x to the 6th minus negative 5, so that's going to be a double negative. So that's x to the 6th minus negative 5. So doing that, that's a double negative, so that's x to the 11th. And then we have y to the 4th. We don't have any y's down here, so we're good, y to the 4th. And then we have a z to the 2nd, so this is where we're going to be. This is if we had just simplified. Inside, I'm going to write out what's on the outside. Just 1 second. So then you would square it at this point. So square 6, because again, this has a imaginary 1 exponent that's not being shown right now. So that's 6 to the 1, so that's 2 times 1. So that's 6 squared. X to the 11th squared, so that's going to be x to the 11th times 2, so that's x to the 22nd. Y to the 4th squared, so that's y to the 8th, because we're multiplying, and then z to the 2nd squared, and that's actually 1 over z squared, so that's going to be 1 over z squared, and that's going to be z to the 4th. So this would be your final answer. Now, like I said, at this point right here, you could have solved this differently. You could have went ahead and multiplied before simplifying. So I'm going to show you that you could have done that and you still get the same answer. That's going to be done in purple for right now. So if you wanted to, you could multiply. So I'm going to multiply 12. And remember, we're not multiplying 12 times 2, we're multiplying their exponents. So I'm giving 12 to the 1, 2 to the 1. I'm writing those imaginary. And please do that, because again, the most common mistake I saw in that test was multiplying the exponent and the coefficient. That's not what we're doing. Because right now, that's like saying 12 times 12 with all the other stuff over again. So like x to the 6 times x to the 6, y to the 4th, yada yada yada. So I'm gonna stop there. I'm gonna erase that. But that's what's going on in it right now when you have that squared value, that square, the exponent on the outside. So 2 times 1 is gonna be, separate this. So this is if you had decided to multiply instead. So 2 times 1 is going to be 12 squared. X to the 6, so squared, so 6 times 2, that's going to be x to the 12th. And then y to the 4th, so y to the 4th, so 4 times 2 is going to be y to the 8th. 1 times 2, so that's going to be 2 squared. And then to the negative 5th squared is going to be x to the negative 10th. And then z squared is going to be z to the 4th. Alright, so now you're going to simplify at this point. So again, this is kind of two different ways you could do this. I'm going to do the way that I'm pretty sure most of y'all are going to do it. You're going to square 12 and then square 2 and then just divide them. You know what I didn't do in the last one? I forgot to square 6. So that would be 36. So your final answer for this one. I'm sorry that I didn't do that, y'all. I'm just going to erase that. So this was going to be, because 6 squared would just be 36, so I'm just running out of room so you can't see that. So 12 squared is going to be 144, and this is going to be 4, so 144 over 4. You have x to the 12th. I'm sorry. Okay. So if you subtract 12 minus 10, minus negative 10, so x to the 12th minus negative 10, that's adding 10, so that's x to the 22nd. Y to the 8th is going to stay the same because we don't have anything to take away from the bottom, and then we have z to the 4th. If you divide 144, give me 1 second because I'm going to bring up the calculator for y'all to see, but I need to switch the calculator to the graphing one. So, 144 divided by 4 is going to be 36. So we still get the same answer. So I'm going to erase this. Oh, and it's probably best if I take that away so you can see that. So I'm going to erase that, and that just becomes a 36. So this is going to be our final answer. And do they match up? Yup. So both of these are fine. Now, let's say you didn't want to simplify. You wanted to go ahead and just multiply the exponents right off the bat and get it over with. So I'm going to solve that in blue, and I'm also going to move this just slightly over so you don't see this anymore. So this is if you had multiplied in first. So again, that's 3 to the 1, 4 to the 1, and 2 to the 1. You have to give those two. So 3 squared becomes 3 squared. X to the 8th squared is going to be x to the 16th. Y to the first squared is going to be y squared. 4 times 4 squared. X to the negative 2, so squared is going to be x to the negative 4th. And y to the third is going to be y to the 6th. All over 2. Yes, yes, yeah, it's fine. You may, yes. This is gonna turn into a TikTok, because that was a TikTok earlier when someone, anyway, x to the negative 10th and z to the 4th. So now, again, you're going to add or subtract. I would just go ahead and add the top and then subtract the bottom once you're all solved out, because there's nothing you have to solve for down here except for 2 squared. So 3 squared is 9. X to the 16th minus 4 is going to be x to the 12th. Y squared plus y, times y to the 6th is going to be y to the 8th. And times 4, times 16. So I'm not going to combine those right yet, because you'll do that. So this is 4 x to the negative 10th, z to the 4th. At this point, you could multiply these, but I wouldn't, because you can do 16 divided by 4 and cancels out like right off the bat. So I would do that. So 16 divided by 4 is going to be 4, so that's going to be 4. So it'd be 4 times 9, and 4 times 9 is going to be 36. X to the 12th minus negative 10 is going to be, so that's going to be x to the 22nd. No y's to cancel out or subtract from the bottom or add to them, and then z to the 4th. So we literally got this same answer 3 different times, 3 different ways. It is up to you. So yeah, so that's all law of exponents. I was just going to stick with that for today. If you would like more questions with law of exponents, please either leave a comment, put something in the chat, or send me an email, or write something in Google Classroom. I don't, either way works. And I will plan for some more problems with law of exponents next week. I'll probably do at least one more next week for still review. But I'm going to at least work on radicals, and today I'm going to do simplifying radicals and multiplying radicals. I will do, again, more simplifying next week with adding too, because I know this last test was either really good or really bad, and I think there was just a little bit of confusion with that, so we're going to work on that. So I'm going to erase this. Oh, and in fact, let me just show y'all, just in case, just to show y'all, everything was the same answer. So either of those ways works. Alright. Clear canvas. So I'm going to write 2 problems up for right now. One's going to be squares, and one's going to be cubes. So let's do squares. We'll do our squares on the left. So squares on the left, I'm going to write those out first, so you can see those. Remember, our squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. I'm going to stop there for right now, but you can continue on. If you forget them, you have a calculator, so you can do those. So this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and continued on. But please brain dump those on a test or quiz or whatnot, because that is going to help you with simplifying. Cubes, I'm going to write on the right over here. Can you see this? Yes, you can see this. So those are going to be 1, 8, 27, 64, and 125. I'm going to stop there. So, I'm going to give you all two problems. The two problems are the square root of 448 and the cube root of 56. So what I am going to do though is I'm going to zoom in and we're going to move this out of the way. Yikes. So we're only going to focus on this one for right now. Alright, so first thing, we need to get factors. Factors that are perfect squares. I am going to show you two ways. Because I had a high school student who came over and showed me another way that they were learning it, and it's okay. My only concern with it is it's going to be a lot more work. You have to write more factors out, and I don't want that for y'all. Without door hinges. I don't understand why you're eating door hinges with your peanut butter and jelly sandwiches, but you can do this one of two ways. 4 is already a factor of this because 4 can go into 4 once, twice, so that can be 4 times 112. That's one answer, but we're not done yet because there's actually another one that's in there. So you can also try to take out other numbers too. So we can try to, let's see if 4 can go in there again. Let me bring up our calculator. Control G. Alright, so 112 divided by 4 comes out to 28, so I can rewrite that again. So 4 times 28, and then I can write this out again because we know 4 is a factor of that, so that's 4 times 4 times 4 times 7. And we know that the square root of 4 is 2. The method, let me get this out of the way so y'all can see. The method that was shown to me is kind of different from here, so I'm gonna show you the method that we learned earlier. So 4 times 4 times 4 actually ends up being 64, so we could have even pulled 64 out instead, so that's one option if you had gone through the squares, or since we did it this way, this is fine as well. Square root of 4 is 2, square root of 4 is 2, and square root of 4 is 2. This mistake is right here that I kept seeing on some of y'all's work. When you factored out your perfect square, you just left it there. Like you just took away the radical, like it wasn't still underneath the radical. That's why, please, when you start to factor things out, leave it underneath the radical. You haven't done that operation yet. So, square root of 4 is 2, so 2 times 2 times 2 is going to be 8, square root of 7. That's one way, okay? You could have factored out 64 if you had wanted to go through each one and divided 448 by each square until you got a number. That's one thing you could have done. Or you can factor like this if you know that 4 is part of it. You can use your lower ones. So this would have been one answer. The other way that was shown to me, and I'm going to bring this further down, so I'm going to start here. Write this in a different color. I have been missing out on the sweet TikTok scene. I bet you there's some good ones going on, I guess, since everybody's home making quality content like Vine. So 4 times 4 times 4 times 7. Now this is what you do not need to do it this way. Again, you do not need to do this way. This is just another way to do this that was shown to me. I think it is much more lengthy to do this process, so that's why I don't show this way. But another thing to do is to keep factoring them out. Let's say you don't know those are perfect squares. So 2 times 2 times 2 times 2 times 2 times 2 times 7. If you see a number twice, that you erase one and that one comes out. You erase one and that number comes out. You erase one and that number comes out. You only have 1 7, so again, you get the same answer. I don't recommend this way. This is just another way that you can do this that I have seen. And that's fine. There's nothing wrong with it. My only issue with it, and this is my opinion, is just that it's lengthy. So it takes a lot more time for you to do that, and I don't want you to be spending too long on the test. I would rather you just back squares. It's a little bit quicker to do. But again, that's another option for you to do. Alright, so perfect cubes. Did anybody have any questions about that? Other than the peanut butter and jelly sandwich question? No? Okay, because I know I just don't want to be rushing too quickly through that. Alright. What are my factors of 56 that are perfect cubes? Well, 27 is probably going to be too high. 64 is definitely too high, and so is 125, so I'm not going to worry about these up here. So if I try to divide 27, I won't get... It's not receiving enough video to maintain smooth streaming as such. What? What is going on? Hold on one second. Y'all may be getting some buffering, but my... Why? My internet is also... Okay, I don't know. You may be getting some buffering issues. If so, I'm sorry. I don't seem to be having any issues with my internet. Oh, the wind is kicking up. That's probably why. So yeah, so if you're having some issues with like dropped frames and stuff like that, just be patient. I'm sorry. It's probably the awesome wind that's happening right now. Anyway, so you can actually factor out a 8. So this is 8 times 7 cube root. And again, this part right here, if you don't, make sure you rewrite that radical. Otherwise, some people were just pulling out the 8, and that's not good. So the cube root of 8 is going to be 2. And that's going to be your final answer. And again, the other way you could have done this is like I was just showing, where you could factor out 8 to its base factors. And if you saw it, if you saw the number 3 times, you would just erase it twice and then pull out the one number that's there. Again, I don't recommend this way, but that is an option as well. So that is the options for that. Alright, this stream is going to run over, so hopefully y'all are okay with that, which you should be. But if you need to go, I understand. Make sure you all are still keeping up with your other work for the other stuff. I know nothing is... It's kind of crazy right now with work and stuff, so... or lack of work. I don't know. So, we're gonna put up some... multiplying radicals. So we got, again, I'm going to do this twice. So square root of 12, I wrote that too big. We're going to start over. Square root times square root of 15. Alright, so hopefully y'all are okay with me just doing different colors as we go through this. So orange is going to be one way. And then green is going to be a different way. So going through orange, I would have simplified first, but that's just me. So some perfect squares that we can pull out of 12 is 4. So we got 4 times, let's write that over a little bit more. And then 15, we don't have anything, so I'm just going to write square root of 15. Square root of 4 is going to be 2. So we got 2 times the square root of 3 times square root of 15. This part right here, 3 times 15 is going to be 2 times, so you're just multiplying what's inside, so 3, and just because we're multiplying, so that's why we're combining what's underneath. So 3 times 15 is going to be 45. And there is another perfect square in there, and that would be 9 times 5, and 9 is a perfect square, so that's going to be 3 times 2 times the square root of 5. 2 times 3 is 6. So that would be your final answer. Now, let's say if you had multiplied first instead. So I'm going to bring up my calculator. Clear. And we're going to do 12 times 5. Sorry, not 12 times 5, 12 times 15. So you get 180. And bring that away, put that down. So if you'd done it this way, you would have done 12 times 15, so you would have started with, let's go this route, so you could have done this way or this. So this would have been the square root of 180. And then at this point, you can then start factoring out values. So if I take out 18, you can see here, so you could have factored out a 9 times 20, and then again you can take out one more, 9 times 4 times 5. Square root of 9 is 3, square root of 4 is 2, 3 times 2 is 6, so you still get the same answer. Now, if you didn't want to take this factored twice, you could have also factored out 36 from 180, just like we had seen earlier. So either of those options are mint. So you just pick which one is best for you. That's 2 ways you could have done that. And I'm going to clear this. I'm going to do one more. One more, and then I will, like I said, I'm going to close the stream down just for a little bit, but I'm going to open it back up in about, if you could give me 15 minutes to edit the stream so it's not like the lengthy beginning and the middle. Actually, I guess what I could do is just leave it open. Never mind, ignore what I just said. I'll just leave it open for a few more hours. If there's any questions, I'm sorry, not a few more hours, for another hour or so. So if you have any other questions after I do this problem, I can work out some more problems. But it's going to be open up to anything, pre-algebra or algebra. But I at least wanted to cover this stuff up real quick. Okay, so last problem for right now. This will be a cube root. So cube root of 48 times cube root of 9. At this point, you could factor out, like I said, simplify here first, or you can multiply that. So we're going to do this 2 ways again. So with multiplying, 48 times 9 is 432 by, so 432 cube rooted, or you could have factored out the 48, that is 8, because that's a perfect cube, times 6, times, I'm going to go ahead and put this underneath, times 9, just put them all together. Cube root of 8 is 2. 6 times 9 is going to be 54. And then at this point, you could pull out another perfect cube, and I'm going to let y'all try to figure that one out as I move on and take out at least an 8 over here. So I want you to tell me what's another perfect cube that you can pull out from 54. While y'all are working on that, I'm just going to at least rewrite this with 8 factored out. calculator. I should have known that one already. But anything? Can we factor out anything from 54 that is a perfect cube? Alright, I'm gonna go ahead and I'm gonna give it to y'all, but it's so that's 27 and 2. Cube root of 27 is 3, so that's 2 times 3 times the cube root of 2. 2 times 3 is 6, so this would be 6 times the cube root of 2. At this point, you could have also, instead of doing it this way, where you would have had 8 times 27 times 2 and done it this way, you could have also pulled out a perfect cube here, and that perfect cube, so 8 times 27 is 216, and the cube root of 216 is just 6, and that would still be your answer. Either of those are mint for selecting your answer. Okay, so again, that's 3 different ways you could have done that. There's that 4th way where if you like expanded it all the way out, but that's up to you. Okay, so at this point, I am going to just pause real quick. I'm going to go get some water and then I'll be right back. So if you could give me just 2 minutes and I'll be right back. You can still use the chat. I will take any questions that y'all have right now, so you can still use the chat or anything to do that, and I'll leave it up for about another, say about another hour, but just give me a minute. I'm going to just go get some water real quick.